Hello and welcome back. We're going to finish this week's conversation off by discussing specifically architectural design patterns. Now, this brings us all the way back to our architecture diagrams that we talked about way earlier in the course, but we're actually going to dive a little bit deeper, learn about a couple different types of architectures and why they might be used. So even though you didn't really have a choice in the architecture you used for this program, for this project, pardon me, we're still going to learn about all these other cool ones that maybe you'll use in your next course or in industry. So we've talked about this before, but what really is software architecture? It's this idea of how our whole system fits together. Architectural design patterns define this system-wide structure, so the actual structure of your whole program and how these major components interact with each other. So this goes beyond talking about design patterns of individual classes or objects, and instead we're talking about how we're shaping the entire flow of our application, how scalable it is, and how maintainable it is for long-term development. So some key characteristics when we're talking about this software architecture concept is we need to understand that when we're designing our system, high level wise, this is going to affect modules, the services, the layers of our project. This is not just about the classes. And it really is going to guide how data flows. We're talking about how responsibilities are going to be divided in between the different classes and layers, and how change and state are actually managed within our program. We're going to talk about a few different ones that influence things like their performance, the testability of your program, the modularity of your program, and how you actually organize your team, like your software development team. So we'll talk about a few. We're not going to get into super crazy details about them all, but hopefully it will whet your appetite for the interesting world of software and system design. So I've got 5 here: layered architecture, MVC, microservices, event-driven architecture, and hexagonal, or ports and adapters. We're going to talk about all of these. The layered architecture we'll start with, but really that's what we've been doing in our projects, right? This isn't going to be the first time we've heard this word. So layered architectures, these are just a few different projects that actually use layered architectures as sort of the basis of their software, of their program. So we have the Spring framework in Java uses a classic 3-tier architecture. A lot of .NET applications use an architecture where they have the UI layer, the business layer, and then the data access layer, or the DAL. This is similar to the 3-tier architecture that we've been using in our projects. There's the Enterprise Java Beans systems, or the EJB for Enterprise Java Beans. And actually a lot of traditional systems use this, like banking, insurance, healthcare. It works really well in these large scale scenarios where we have complex problems that we want to solve as simply as we can. And we've used these in our projects, of course. We're going to get into the model view controller architecture shortly, but for now, just to get an idea of different projects or languages that use this model view controller architecture, we have Ruby on Rails, Django, which is part of Python. This follows an MTV architecture, but it's very similar to MVC. We have ASP.NET MVC architecture, Spring MVC, Angular, if you've ever done any web-based Angular work, and other web applications with user-facing UIs. In fact, a lot of our UIs in our projects are going to start to drift into this restructure of an MVC architecture. And so that's why we're going to dig deeper into it in just a minute. Now, microservices are the backbone of modern cloud-native architecture because we need all of these different little pieces to all work together really nicely. We've got Netflix, which is pioneered cloud-native microservices at a massive scale, right? We have Amazon. They have 2 pizza teams, which gave small groups ownership over their own services. So each individual team actually gets to own their own services. We have the Spotify. Spotify empowers autonomous feature teams to basically deploy at their own speed, and they can deploy their own services this way because they're all sort of independent from each other. I mean, Uber is coordinating hundreds of services for rides, for payment, for logistics, for grocery shopping now, right? For ordering takeout. It's a massive team of a bunch of small services. All of these different companies and the way that they're structuring their microservices, this is all enabled by pipelines of behind the scenes DevOps, so using things like Docker, Kubernetes, REST and gRPC APIs, different continuous integration and deployment pipelines. These are all things that you might learn about in 4350, so in the Software Engineering 2 course, but for right now we can just understand that we have all of these nice little packaged up services that get to work together to create large scale products. Then we have event-driven architectures. So companies like Airbnb, Uber, eBay, and Slack will use event-driven architectures. And so companies like Uber can use event-driven architecture for things like real-time coordination of where cars are at. We've got Airbnb using it for event streams for like analytics and different user behavior when users do certain things. Other analytics can be logged and watched. So we can see that this is often combined with microservices because each microservice can then sort of be living in its own world. And then as events are triggered in different microservices, it can propagate to the right space. The last one I'm going to talk about here is hexagonal architecture. It's also known as ports and adapters. And this is really just about keeping the business logic at the center of your program. So we want to isolate it from external concerns like the database or the front end, the UI. It's very popular in domain-driven design sort of culture and communities. And we see it in languages such as Clojure. We also see it in frameworks like Spring Boot. We're looking for places where interfaces act as ports and implementations act as adapters. And when we say adapters, I do mean like our adapter patterns that we were talking about. This approach makes a lot of applications a lot more testable and flexible because they're all in their own little spaces and we have those adapters to help connect things together. It makes it a lot more resilient to change as well. Okay, cool. So that's 5 different types of architectures that sort of exist. By no means is this list a complete list, but it is sort of a starting place for all the different options that might be out there. Now we're going to sort of focus back in on the MVC, the Model View Controller architecture, so that we can learn a little bit more about how we might want to implement this in our projects. Now that our projects are growing in scope and our front end is becoming a little bit more complicated. So let's talk about this idea of Model View Controller, or MVC. We have 3 components in this architecture: the model, the view, and the controller. And it's important we understand the roles for each of these. So we have our model, which actually holds the data and the business logic. It knows what to do, but it doesn't know how to display it. In our purposes, we're not talking about MVC on a full project scale. We're talking about it on a front-end scale. So something like a model can hold the information like if we got an invalid response back or if there was an exception thrown. So it's that kind of business logic, UI-related business logic within our projects, because we are talking about using this architecture just within one package, not as an overarching architecture for our project. Oh, sorry. Then we have the view. The view is what actually does the displaying of data, right? This is totally passive. It just sits there. It waits for updates from the model or for actions from the controller, and its only job is to display them. Lastly, we have the controller, and this is what actually responds to user input, and it would update the model. The controller can also trigger view updates. Okay, so let's take a look here. We have a controller action listener here. So let's imagine that we have some kind of like a restaurant, and first we need a model, right? We need the kitchen. The kitchen actually makes the food. The view is going to be the waiter that like brings you the menu, serves you the food, and then the controller is you. You are the one who places the order and gives the command. So you send the order in saying, this is the food that I want to order, and you do it through the waiter. So the waiter takes your order. And what does the waiter do? It takes it to the kitchen, right? It takes it to that model. It's going to make the food in the back. And then once it's finished, it's going to come back through the view and say, here's your food, and serve you the food. We can see that happening right here in a controller. Here we have this button action listener. We can see that the controller, this action listener, is going to call the model. So we're going to update the name. We get the text field right here. So this is coming from the view. The view gives us this text field, and we're able to update the name in the model. And then once we've completed that, the controller can then refresh the view and get the menu coming, or pardon me, the dish coming back, right? So we've got this update happening as like placing This is us placing our order with our server. The server is taking it back to the kitchen, right? The view. It goes to the kitchen, and then the view is the server bringing you your food back. That's our refresh. What we need to notice here is we're talking about a separation of concerns, right? The changes in the UI, if we want to change what the UI looks like, if we want to change to a different server, it is not going to break the logic, right? If the kitchen gets a new chef and things are changing in the back, the front end is not going to be affected by that. The waiter can still do their job. If you don't order, but instead your partner orders or a whole different family comes in and starts ordering, the kitchen and the waiter, they are not affected by this change at all. We have this beautiful separation of concerns when we talk about it in terms of a restaurant, and we really want to emulate that in our MVC architecture. Okay, so now let's dig a little bit deeper into this layered architecture. Now it's very similar to what we've been using. We use a 3-layer architecture system. Here I'm going to show you a 4-layer system. Again, very, very similar. We just don't have an infrastructure layer because our projects, they don't need one. But what we can see happening here is we have all 4 layers listed, and we can talk about the responsibility of each layer. Some of you may have something that looks a bit like an infrastructure layer. You've been calling it maybe utility or like helpers, but that's okay. That's no problem. That's totally reasonable as well. So let's talk about the responsibilities of each of these. We have the presentation layer. It's responsible for handling the input and output and any UI logic. When I say UI logic, we're talking about maybe having an MVC sort of architecture within this layer. Then we have our service layer. This is where, or our logic layer, our business layer. This is where our business rules live and our domain logic is actually going to live within our projects. We have the persistence layer. This is what actually communicates to our database. So a reminder that in like a real scale application, we may need to talk to a database that isn't actually within our code base, right? We might be trying to connect over the network to a database that lives somewhere else. This is that layer. This is what is going to communicate with our databases. In our projects, we're basically just using a file system. Often, depends, I guess, on when you're watching this video, but the file system can be our database, and this layer is what communicates with that file system. Basically, it's just CRUD operations, right? Create, read, update, delete. It's not logic-based. It's purely that communication to the database. And then if you have one, you have an infrastructure layer, and this is where our external systems might live. So any sort of like email senders or loggers or notifications or Stripe client gateways, payment gateways in general, payment processor gateways, right? So third-party API connections. All of this can often live in an infrastructure layer. So just like in an office, if you need a paperclip, you're not going to go ask the CEO for a paperclip because that'd be crazy pants. Each layer has its own responsibility. You would ask maybe the office administrator or a receptionist or an executive assistant, right? The receptionist can ask the administrator asks the supply team, and the supply team says, oh my gosh, we don't have any paper clips in inventory. We're going to have to go and buy some, right? Each layer has a role. So what is your role as a user? What is the role of the controller, the UI? What is the role of the service layer and of the repository? We can see that the controller is in charge of using or calling the service layer. It doesn't talk to the logging or email services. It doesn't talk to the repository. It only talks to the service layer. We can also see that the service layer, following its arrows, talks to the logging and email services, or the service layer here talks to, uses, calls the repository. But the service layer doesn't actually use the controller, right? It might use data that came from the controller, but it doesn't go asking the controller for anything because that's not what's really driving our program forward. The controller drives our program forward. And similarly, our email service, our logging, it doesn't need to go and talk directly to the database. It's its own infrastructure layer in this example here. And similarly, our repository, right? The repository can talk to a database elsewhere within this file system. It's not asking for information from any of these other layers. So everybody has their own role. Now, there are a lot of benefits for this layered approach or an MVC approach or a hybrid combination thereof, right? We have this clear separation of concerns. We have our logic, our UI, and our data access layers, and they all live in different places. So there's considerably less chaos, and developers can work on a different layer or a different part of the system without sort of stepping on each other's toes. Now, when we first set up a project, sometimes it's unavoidable to step on each other's toes, but we really see the benefit once we're ready to start adding new features to our code base. It's also way easier to test, right? We can test our business logic, and we don't need to spin up the UI to do it. Each layer and component can be mocked independently of each other or stubbed independently of each other, and then we can achieve isolation in writing our unit and our integration tests in a meaningful way. We also have way faster onboarding because new devs can just take their time to understand the system one layer at a time. Having a really nice predictable structure means that we have less ramp up time. And we see this benefit when we add new team members to our team, or we have an intern coming in, or we have somebody moving from one team over there to our team and trying to understand the system in which we're using. We have much better maintainability in a layered system like this. It's a lot easier for us to change the tech in one part of the system without risking bugs spreading across to what would be seemingly unrelated parts of the code. So we really see the benefit in long-term projects of why it's so maintainable. And lastly, we have this idea of reusability. If we have nice decoupling because of that separation of concerns, our service or our logic layers could be used across different UIs, right? So if we want to develop for both a web-based application and a mobile application, they can share the same backend because of this nice separate layering system. Now, when it comes to choosing the right architecture for our projects, you know, your instructor, we told you what you had to use. You didn't get to have this conversation. We said you are using a layered architecture. But in the reality, in the real world, there are some good questions that we can ask ourselves to sort of help guide this conversation, like what are we actually building? How many people will be working on it? What are the main priorities for it? And how volatile are these requirements? Are they going to change? Do we have a lot of plug and play components, stuff like that? We need to figure out how complex the domain logic actually is. Meaning like, are we working in healthcare? Are we working in a banking system? Is this aerospace? Stuff like that. Like, how complex is the system we're working in? And will the parts of our system evolve or be reused independently? If they are, we might need more of a modular or hexagonal architecture so that we can sort of allow each of the parts of our system to evolve independently. When we're discussing this with our teams in the future, we can ask things like, what might change in our project over the next 6 to 12 months? How flexible do we need to be, right? Do we need to be able to test our pieces independently? Probably. Drive separation and interfaces that can help us figure out how we want to do those separations. How much tech debt can we actually afford? How much time do we have to deal with that? Because if we don't have a lot of time, it can really influence how much structure we want to add up front versus maybe we'll just fix it and refactor it later. We also want to ask ourselves who else needs to understand our code, because this can really help shape the simplicity or the complexity of our code base. Are we working with data scientists? Are we working with elementary school children who want to learn how to write Minecraft mods, right? We have to really ask ourselves, who is our audience? Who's going to be using this code now and in the future? So at this point, we're going to take a beat. We're going to look at our own projects. Let's go and reflect on them for a second. And I want you to go and label the parts of your own project using either MVC or layered terms. And where do those responsibilities really start to blur? How good of a job have we done in separating the concerns of our own project? Now, in doing this, you may need some terminologies that you should be considering and using to label your project. And I have a whole whack of terms here that I want you to consider. So we have some MVC terms like domain logic or validation logic, output formatting, orchestration of our model and view. Those are all of our MVC terms. We have some layered architecture terms like our presentation layer and where those different pieces fit together, our service layer, our persistence layer, repositories, operations, and the infrastructure layer, which might have API clients. They won't in our projects because we don't really use third-party APIs, but there might be file access, there might be loggers, and you might be fudging some of that like notification-based system logic in there as well. So take some time, go through your project, see if you can sort of label some of those words, or maybe there are some responsibilities that you don't know how to label, and this is a great opportunity to flesh those out a little bit more and see if you can classify them. Once you've done that, you're all done this week's material, as this was the end of our lecture on architectural design patterns and how we can use them and discuss them in our groups. And I will see everybody in the next video, in next week's videos. Thanks. See you later.